Hey friend, I heard that you were having a little bit of trouble with some sections that were required for you to do. So here's what we're going to do. We're going to talk about some of those sections. So I'm looking at section L1 in 8th grade math. And the first question I have here is that we're going to take 12 inches and we're going to convert it into feet. There's a number of ways that we could do that and talk about it. And I hope that you know 12 inches would be 1 foot, and that would be correct. And basically, that's the fact that you need to know to get through this problem. So we kind of did a convoluted, long way when we were learning this earlier. When we were learning this earlier in the year or last academic year. So here's how I'd tell you to do it. I would say, okay, if I'm starting off with 12 inches and I need to get to feet, I'm going to multiply it by something, hopefully, that can cancel out the inches and bring me straight to feet. So do I have any sort of conversion factor? The conversion factor I know is that 1 foot is equal to 12 inches. Because of this fact, when I write something like this, 1 foot over 12 inches, or 12 inches over 1 foot, they both are pretty much like the same thing over the same thing. It's kind of like a number 1. So if I multiply anything by the number 1, I get the same thing back. I don't change the inherent value, but I can change the way something looks, and that's what's going to happen here. So here are what I'm going to refer to as my unit conversion factors, right? Because in essence, this represents the unit number 1, and this represents 1 as well. I want to change inches to feet. So I would put 1 foot at the top and 12 inches at the bottom, because when I multiply this through, my inches will cancel out and I'll be left with feet on the top. As we know, the answer is 1 foot, so that's not particularly a deep question. Let's try another one. So I'm going to put the 1 foot in here, put the number 1, and submit it, and life is good. Yay! So now I've got 12 yards and inches, and so I'm going to bring back up my little opportunity to write board here, my writing board at the bottom. Okay, so check this out. So I'm looking at it and I'm thinking, all right, how am I going to do this? 75 yards in inches. Well, what we would want to know is, do we know any conversion factor? Do we know any kind of relationship between yards and inches? And let's say you don't. Let's say you're like, I have no idea how many inches are in a yard, but I do know that there's 3 feet in one yard, right? So I'm going to write it like that. And realize that I can write now, given that fact, 3 feet over 1 yard as a conversion factor, or 1 yard over 3 feet, okay? And then, that doesn't bring me to inches yet, but then, just from the last conversation that we had, I have 1 foot is equal to 12 inches. And so that brings me back to the conversion factor, inches. I can spell it, I promise. Inches, and that brings me back to the conversion factor that I used before. So I know that I can write it as 1 foot over 12 inches, or 12 inches over 1 foot. Now you're saying, that's fun, Dion. However, how does that lead us to our answer? Well, let's start back here. If I have 75 yards, and I'm trying to change them to inches. First of all, before we even do it, let's think about what this answer should be. 75 yards, big things, and how many little things does that equal up? You should think that if I've got 75 yards and there's a lot of these little things in it, it's going to be a pretty big number. So with that in mind, we're going to do 75 times, and now I'm trying to get rid of yards to move to inches, but neither of these does that. This one gets me yards to feet, and then this one will get me feet to inches. And so I think that's a good plan. I'm going to change my yards to feet. I'm going to give you a little space here. So at the top, I'm going to put 3 feet. And at the bottom, I'm going to put 1 yard. Notice my yards will cancel out and I'll be left with feet. So basically, if I just went from here to here, 75 times 3 is going to give me the number of feet that I have, right? And now I'm not done, because I need to change my feet that this is going to result into inches. And so what I'm going to do is use the conversion factor that would change my feet into inches. So I'm going to put the inches at the top, 12 inches at the top, because I want inches, and 1 foot at the bottom. Swoop delicious. I cancel those out. And what I'm going to get, I will get my answer by multiplying 75 times 3 times 12. And I'm going to pick up a calculator and do that. Not that I couldn't do it in my head, but I don't want to do it in my head. So 75 times 3 times 12 is going to give us 2,700 or 2,700 inches. We're going to go and put it in here just to feel confident that we did it right. So 2,700, and we feel awesome because they tell us that we're fantastic. Same thing with pounds and ounces. I'm going to do this last problem in this section, and I'm going to hope that this will be helpful, and I'll move on to a different section. So let me get my board up again. Okay, so as I look at 78 pounds, I need to know the relationship between pounds and ounces. And by the way, if these relationships aren't coming to you, feel free to go on the web and just figure out how many pounds are in an ounce and stuff like that. That's totally fine. So what I do know is that in 1 pound, let me write this down, in 1 pound, and we know we use LB as the abbreviation, there are 16 ounces, okay? And these are weight measures, not liquid ones. Liquid ones have, there's like 8 ounces in 1 cup and the whole 9 and 2 cups in 1 pint and blah, blah, blah. So I would look for a conversion chart from right online, and that'll be fine. Okay, so here we are. We've got 1 pound, 16 ounces. What am I going to do here? I need to go from 78 pounds to however many ounces, right? How am I going to do that? I'm simply going to use this conversion factor because it's perfect. The conversion, I'm going to change it to a conversion factor. 16 ounces can go over 1 pound, or 1 pound LB. That's kind of confusing looking. I'm going to make that a fancy one. So you're like, oh yeah, I understand exactly what you're doing, Dion. Over 16 ounces. So these are the two things that I can use. I can use either one. To use pounds over ounces, my pounds won't cross out. I'll have ounces at the bottom, pounds squared at the top. That's pretty weird. So it makes sense that I'm going to put the ounces on top because that's what I want. So I'm going to have 16 ounces at the top, 1, fancy 1, pound at the bottom. My pounds will cancel out, and I'll end up with whatever that is. 78 times 16 is going to give me 1,248 ounces. Plug it in. Let's make sure we're good. And 1,248. And I'm doing a little dance. I'm feeling good about myself. So now I'm going to move on. Like, I feel like that should be sufficient for you. So I'm going to move back on. I'm going to check out L2. Converting rates and measurements. So now what we're talking about is metric rates, and that's a little bit different, but again, you can find information online to help you out with this. So the cool thing about the metric system is this: everything is done in multiples of 10, but it's really necessary to keep in mind like how the prefixes really help you understand, is it a tenth, is it a hundredth, is it a thousandth, is it 10 times? Is it 100 times? Is it 1,000 times? So that's what we're going to talk about really quick. So this is a quick mini lesson. This is also, you can find this online. This is something we haven't talked about explicitly, but we did deal with these a little bit when we dealt with kilograms and kilometers and things like that. So in this system, let me get a smaller pen so I have more space. In this system, you're going to have kilos. You'll have hectos, sometimes hecto. This one isn't used very often, and you'll see that. Deca. And I'm going to just put a box here and put the word unit, and it'll make sense in a minute. And then deci, centi, you probably use the centimeters, and millimeters and milli, okay? So how this works out is like this. You'll have a unit. Let's say you're dealing with meters. You know meter is a distance. So now if I talk about decimeters, I don't know if I want to write that. If I talk about decimeters, I'm not going to write it because I'm not going to have the space. If I talk about decimeters, I'm talking about 1/10 of a meter. If I talk about centimeters, I'm talking about 1/100th of a meter. If I talk about milliliters, I'm talking about 1,000th, so super tiny. So I'm going to put on top of deci 1/10, centi 1/100th, got it, and milli 1/1000th. This is the unit meter. Sometimes it could be liter, so I could have deciliters, centiliters, milliliters. And I could also have grams when we're talking about weight. So we've got distance, we've got liquid volume measure, and we've got weight. So we can have decigrams, centigrams, milligrams, but on the other side, this is 10 times. A decameter would be 10 meters, okay? A hectometer would be 100 meters, and a kilometer, which we're used to, is 1,000 meters, okay? So again, I could write out the different words, but I'm not going to because I don't really have the space. But what I want you to see is that it's really pretty simple. You just have to kind of figure out how many tenths they are away from one another. So we're going to look at the problem that we have here using this little device that we have down here. Okay, so as I'm looking at this problem, I changed the problem because I had some technical difficulties earlier. I'm looking at 240 milligrams, and I'm trying to change it to centigrams. So centi and milli, I'm thinking about those. So I'm going to slide down a little bit. You remember the order. And I'm going to slide down here and think about, okay, so I know that if I have 1 centimeter or centi anything, it's equal to 10 milli, whatever they are, in this case, milligrams and centigrams. So my conversion factor for this problem, since I want to go from milli to centi, is going to put 1 centigram at the top, right? And then put 10 milligrams at the bottom. So when I do that, and I use this to convert what we have, I'm going to have 240 milligrams. I'm going to be lazy right now and not write all that, times 1 centigram over 10 milligrams. Swoop delicious. I'm canceling out the millis. That goes in. I end up with 24 centigrams. And so I'm going to go over here, put 24 in, and hope for the best. And I'm feeling fantastic. And you see how this is going. So the key, hopefully, is for you to keep this relationship in mind. And every jump is 10. So here, when I'm looking at meters to millimeters, so this is 10, 20, I'm sorry, that was silly, 10, 100, 1,000. So 1 meter is equal to 1,000 millimeters. All right, we can talk about that one if you'd like to. Since this is L2, I kind of want to see if I can do the whole thing in the video for you, just do one little 15-minute video, so I'm not making you crazy. We're going to look back at, I think X8 was the other topic that you had that may have been causing a little problem. So here's X8. So when I look at this type of problem, let me pull up my board. I want you to know that this is just like solving any old equation that you've solved before tons of times. So if I have 2 minus a negative 1h is less than 4, I'm looking at this negative, this less than symbol is almost as if it's an equal sign, okay? So as I take a look at this, I'm going to move everything over to one side of the equation. So I'm going to isolate my variable. Remember this? Any of this sound familiar? So let's say that this side is going to be my h side. This side is going to be my regular number or constant side. I'm going to get rid of the 2, subtract 2 from both sides. When I do that, I'm left with a negative. I'm subtracting a minus 1h is less than or equal to. Now, minus is a plus, so that's really 1h is less than 4 plus a negative 2 is going to give me 2. So h is less than 2. I don't think they're asking you to graph this, but if you were, you'd find 2 on the number line. This would be an open circle, and you would shade to the left because h is less than. So you want things that are less than 2. Let's look at another problem. Oh, I'm sorry. How are we supposed to do this? So I'm supposed to write this. So h, they gave me a chance, h is less than 2, according to me. Let's see. Hopefully we're right, and they think we're terrific. Okay, so let's look at another problem. Let's see if we can apply this same logic. Coming down here, let's see. I have t over 4 minus 8 is greater than negative 10. I'm going to add 8 to both sides. Right? Again, I'm isolating my variable term, and this is t over 4 at this time. So I've got t over 4 is greater than, look at this, negative 10 plus 8 is going to give me a negative 2. Now, how do I get this t by itself? Remember, when I look at this, I'm actually considering it an equal sign. Sometimes we got to worry about the sign, but for the most part, we're just going to leave it the same as it is. So what I'm going to do is multiply both sides by 4. I see that my time is running out. Let me know if I can help you some more. I'll talk to you soon. Bye-bye. Sorry. Bye-bye.